Awesome. So thank you very much, Stefan, for the intro. And it's a real honor to be here because it's my very first pure Clojure conference, but also just it's really amazing to be part of this community, which Clojure has in a way opened so many pathways to me in the last 5 years now, since I've been using it. And I just want to share a little bit of my journey, because I think if you are part of the mailing list, the Clojure mailing list, there's definitely a strong bias towards mainly web development. And I think it's a little bit sad that there is even though the language is so powerful and enables so many people to do stuff more efficiently and just also approach how we've done stuff in the past from a quite different angle in many fields, and there are so many ideas which have infiltrated other language camps that at large the Clojure community is still pretty much focused on the web development. And of course, there are a lot of people, not just me. I'm not putting myself here out as some form of speciality at all. But I just want to give you some examples. Maybe you will find interesting also to see how you might be able to use Clojure in very different contexts than what you usually read about in blogs and on conferences. So just very quickly, I've been running a little practice called Post Spectacular since 2007. And I'm living in London and work in London. And I'm mainly doing, it's really hard to summarize what I'm doing because I'm kind of a jack of all trades. But the underlying common denominator really is this computational design approach. So trying to solve mainly design problems from or through computational means. And I also made, at the very beginning, basically set this out as a mission statement to do as much as possible as open source. And I was lucky enough over the last 8 years, really, 9 years almost, to work with quite a large range of clients on basically doing what I do. And another big part is that I as part of my activity, also do teaching at universities and do short workshops, intense workshops about those topics. I will talk about this a little bit later. So one of my really guiding philosophies is this quote by Wittgenstein, which I think is very much summarizing my relationship with computing technology since I really have been a teenager. And I really also think it goes very nicely together with that quote from the Bible. And I think any language, or if we talk about computing languages, I think we all can see ourselves a little bit in that. So a little bit, language is playing a big role in my work, and I also want to quickly really have you to understand this. I see language, not just programming languages, but language in general, really as a medium, basically a platform for expression. And if we talk about programming languages, these are the ones in not chronological order, but alphabetical, what I've been spending my time with. And it's really, in every camp you realize that that each language could learn a lot more from the others, but also that in each camp you have people who try to solve every problem with that one language. So of course you can do 3D graphics in brainfuck, sorry to say, but would you really want to? Here is an extreme example. And another point here to make is that if you look at them, most of the languages are pretty commonplace, but if you look at them, you also understand that some of them operate on different levels of abstraction. And over the last 25 plus years, I've kind of climbed up that ladder of abstraction and worked with a lot of high-level languages, but I recently, in the last 2 years, actually kind of fell off that ladder, and I'm spending more and more time also in the very low-level parts, which I have a lot of fun with, because I think, for instance, in Clojure, as I said, for me, it has opened so many pathways in terms of thinking about how problems can be solved. If you take those learnings from those higher-level languages and apply them to something like, for instance, assembly or C, you actually can get to really new conclusions. But in general, I think it is not so much about those general-purpose languages we are using. I think what is far more important is that we talk about more those domain-specific languages, because this is really the bread and butter for solving problems. And for me, as I said earlier, my main context for operating is somewhat design-related. So for me, this is really important that I have a language which allows me to solve problems in that field. And another important thing is a lot of designers always talk about this mystical thing of design. I don't believe this at all. For me, design is simply an action and a process, and that's why a functional language is actually very well suited to think about it. And another issue I have with design in the traditional sense is that so much of design is about sampling. It's cultural sampling, and it's simply kind of repurposing existing things. And I've always been more interested in the kind of synthesis part. And there's a nice analogy in music. If you start playing around with synthesizers, you start from pure waveforms most of the time, and then you start defining processes to create more complex entities. So before I started working with Clojure, the language which I worked on myself for 7 years before that was this project. It still is going, but it's really not that much maintained anymore. And that, in the background, is a map of that library. So that's about 320 building blocks or classes for mainly Java. And that allowed you to do anything from geometry in different dimensions to color theory, physics simulations, audio processing, music composition, and so on. So this was really part of the initial business plan I had, that every project I work on commercially somewhat funds the further development of those libraries, and they have been used by like thousands of people in that field. So some examples now, before I get to this, so my main problem when I started with Clojure was that I kind of had to start from scratch. I've done 15 years of Java before that, and I basically had no tooling at all when I started with Clojure, or at least no tooling for the things I wanted to solve. But then luckily there was a project opportunity I've been asked to contribute, which was this Google Web Lab project. And that was a collaboration between the Science Museum in London, the Google Creative Lab, TelArt, BeReal, and Universal Design Studio. And this was a one-year exhibition at the Science Museum, and it was the first opportunity, like commercially, to use Clojure for that. But not just Clojure alone, but really as part of a big mix of other languages and technologies. So I just need a quick sip of water. So there were it was a really large project, probably the largest project I ever worked on. It lasted almost 2 years to develop in total. And one of my first tasks was to develop those so-called lab tags, which were handed out to all visitors to the exhibition. And you can see this dot pattern here on the side. This is a computer vision marker system I developed. It's all done in Clojure. We printed about 750,000 of those cards, because that's how many visitors, or physical visitors, the exhibition had. And everyone who arrived at the exhibition then went to one of those dispenser machines, got their own lab tag. Yeah, that's here an image of the machine. And then people used those lab tags to basically touch in and out on the different exhibits. And in those machines, you had a decoder application running, also written in Clojure in OpenCL, which then looked like this. I mean, that's a screenshot of the decoder, which then reads the pattern and basically identifies the visitor and attaches information, what they do, and then they can recall this via the website after they left the exhibition. The second part of the project was to write the software for this 10-meter wide projection wall. And this was basically to visualize all the different visitors who are currently in the exhibition, both in the museum and online. And you can see there are some line drawings as well, not in this picture, but here you can see a shadow. And that's actually an industrial robot arm, which was designed by Tellart, the company I worked with. And that robot arm was controlled in conjunction with the software I wrote and by someone else from Tellart. So it was really a great team effort. And this whole visualization was all written in Clojure as well, partly at least. And here you can see some development screenshot of that, how it actually looks. How it looks, not what people were seeing, but what the actual environment is. So you can see those 3 screens, they're actually 10 meters wide. The whole challenge was to make everything run in Chrome. So there's actually a physics simulation I will show you next, which is here. Let's try and make this bigger. No. Let's try and make this bigger. So here you can see there's some flocking going on. So in all those symbols which are flying around are representing those unique ID numbers from the lab tags. And then we had about 10 different visualization modes which were triggered on a timeline repeatedly. And one of those modes you can see here is where those visitors slowly fill up the WebLab logo. But then other visualization modes were to, for instance, show how many visitors, and this is mainly for online visitors really, are, for instance, from Australia or from America, or what exhibits are being watched by how many people at the moment. And the whole thing had to basically transition smoothly between those different states. So here you can see after a while, those letter shapes break apart again. And this was a huge challenge to really achieve this in Clojure. So there's the physics simulation, because I simply could not make this run fast enough. The physics simulation was written in Java. And there's a WebSocket server which then submits all the positions 30 times a second to the application running in the browser. Another example of an early stage of my Clojure work was this exhibition here for the V&A Museum in London. And this was a projection mapping installation. And I've always been very interested in geometry and the amazing shapes you can get, for instance, from applying a fractal approach. Not a fractal approach as necessarily like Mandelbrot proposed, but really applying this idea of recursiveness to create new forms. So and if you take even a simple polygon, it's a bit cropped, that image. If you take a simple polygon and you start splitting it into smaller pieces, then you can end up with only a handful, or like more than a handful, but still a small amount of unique shapes. And if you then define a process which reassembles them, then you can create something like this. Here, it's just switch the order. So, and this machine here is a basically very cheap means of physical fabrication, which is simply a plotting cutter. So I designed a Victorian-style room divider, which was covered in those kind of polygons, and then used as a projection surface. So, and for instance, here you can see that those kind of problems, design problems, are very hard to solve with just plain Clojure. What is really needed to work on something like this is a language which allows you to work more conceptually with shapes and with geometry in general. And then also other issues, for instance, exporting shapes in a file format, for instance, a digital or a physical machine understands. Things like this. And there's really not enough tooling for those kind of applications in the Clojure community. So I kind of took it on myself to develop that because I want to use Clojure, because I think it's such a great language. But at that point, at least, there were not many other people in that field interested in it. So this is a 2.40 meter wide laser cutter, which then cut those room dividers. And then over 3 months, every night, I was cutting over 600 of those paper cones on this cutting plotter. Here they are all nicely packed up. And then my wife and some friends unfolded them all. And then it took us 4 adults and 2 full days to stick them into those frames to create that surface. And then the final step was to have an application which is basically projecting onto those polygons. And I had an iPad application which was embedded in that table you saw earlier, where then visitors can choose a shape and apply different patterns on that shape and always create ever more variations. And the best compliment I got was that someone said he forgot his LSD, which is allowed to say in an art museum. Okay, so the next project is something I need to show here in person. So this was from 2013 now. And this was a branding project I did with a company called Precedent in London. And where is, sorry, wrong folder. Here it is. So this was the first desktop Clojure app I ever built. And what's special about it is that it actually heavily uses the GPU for computation, but not only OpenGL, which is the standard software layer for doing accelerated graphics, but also OpenCL. And the reason I needed OpenCL is because this sphere here is actually constructed at a moment of 3.2 million particles. And I can do this, I can update this pretty fast, as you can see. But in Clojure, every single value change would take almost a minute. So just to put things in perspective, whenever we say that Clojure is actually pretty fast, this is relatively to what? Now, I'm not trying to criticize Clojure. I just want that we can have an honest conversation about those things. And that I really think optimization is often relegated in the Clojure community as something which needs to be too carefully thought of. And there were also some social experiences with other people. I won't tell now any names. People who are in the community know about this, where then work is being removed again, important work. And I think there are applications where those kind of optimizations really do wonders and actually mean the threshold between being able to use Clojure and not. And at the same time, Here are some other examples. Have to go presets. So you can just drag and drop preset constellations here. So this entire user face is basically all built with a tiny GUI library I wrote, and everything is done in OpenGL. Those interface elements. And then when you press one of those buttons here on the right, it actually submits that image or the description for that scene at the moment to a render farm, which is spawned ad hoc on Amazon. And then the client will get an email notification a few hours later when it has rendered a video of that version. So there are some more examples online on my YouTube. I will show you the link later. So this was the last project I did before I started this project, the Thing project, if you can't read that, which I don't blame you for. So this is really my current labor of love for the last, well, 3 years almost. And at the moment, this is basically the same kind of thinking what I used for Toxic Clips. So it's consisting currently of 23 different projects and a few more unreleased ones. But it's really aimed to provide open source tools for people interested in Clojure and in this kind of work, and also provide learning resources around that, for instance, in the form of workshops, but also write all the source code as much as possible in a literate programming style. So the literate programming style is something which was proposed by Donald Knuth, and with the argument that we should write first a description of what our code does before we actually write a single line of code. And of course, we can't always do that, especially not in an environment which has form of deadline. You know, Knuth wrote how long on tag? Who remembers? How long did it take? Yeah, a decade or so. So this is fine to do that. But in general, I think it's a very good approach, and at the same time, I also do get criticized by people that it stops people from contributing, which I admit is an issue, because the only way to properly do literate programming seems to be in Emacs. If someone has alternatives, proposals, I would very much like to hear about them. But I also mentioned there are training courses, so you can find upcoming ones on this website. So, and one of the examples I want to show here, one of those libraries is, for instance, called Morphogen. So this is about a very small, I almost don't dare to say language because it's so tiny. It only has 8 different verbs. And it's kind of an assembly language for 3D geometry, but very constrained one. So you can, for instance, create forms like this. And the interesting part here is that this hexagon grid has been created from one single segment. For instance, this segment down here, which I'm outlining with my mouse. And then if you apply the same code in that language to another initial seed shape, which has slightly different angles, then suddenly that code folds, for instance, into a hemisphere. And here's, you can see another object where the process is in action. So each frame in this animation is descending one level further down into the syntax tree of that program. And this is basically the Clojure code which is needed to do that whole object, including exporting as STL files so you can 3D print it. So what I found really interesting by working on this project was that those Clojure is also perfect for visualizing actually code structures. And I'm actually working, I mean, not seriously at the moment, there's no real project yet, but I'm actually working on a similar approach to visualize code trees for Clojure. So for instance, this object here, again, generated from a single tiny box, really, suddenly starts unfolding and refolding into something like this. But the code visualized looks like this, and I find alone those diagrams actually almost more beautiful than the object. So in here you can see that you have a single seed shape at the beginning, and then that starts branching into more and deeper, more filigree structures. Here's another example. And this one looks like this, visualized. So of course, GraphViz is your friend. Finally, what is very powerful also in this approach, maybe you remember this object here. Let me just rewind. So taking the code for this object description and transplanting more elements recursively on each of those final leaves of that original tree, we can then, for instance, kind of copy-paste features, or I almost think about it as DNA subsequences onto that existing object to create something completely new. So there's also a big potential, for instance, to apply evolutionary techniques like genetic programming, where you can just splice random parts of a tree into another tree and see what comes out. So, and then this project really was developed as part of this commission, which was a joint commission by Google and the Barbican Center in London. This was 2 years ago now. So this entire structure has been designed with that morphogen language, and it's basically 3.5 meter tall 3D printed sculpture, including here the cladding for those plinths as well. And here's another view. So here in the center of that sculpture is a 3D printer, which I built myself based on some open source DIY kit. And this actually uses liquid and a modified hacked video projector where you remove the color wheel and it only emits UV light, which then is hardening and crystallizing a really thin layer in the liquid. And the entire application here is sitting inside that plinth on a Raspberry Pi. And you also have 7 more Raspberry Pis here in the shelf, which is driving, or which are driving the LCD displays. So the whole thing is open source on my GitHub. And it was the first time I really seriously used Clojurescript in anger. And at the end, it was really in anger because this was before there was Figwheel and when everything was still very painful, but I'm a tour de force sometimes. So it was also, I think, for me, a very great opportunity to actually show what you can do with those libraries, because it almost combined every single part, including, for instance, doing the installation design for the exhibit, because there were so many different partners involved in that project, which always wanted to be updated. So the entire scene for how the installation would look is one big Clojure file. If someone changed their mind, for instance, the diameter of that truss which is holding the structure, I just change one variable in the code and regenerate the entire geometry, which would have been days of work if you would design this manually. Here are some close-ups of those panels which create the structure, so they are shape-shifting as they go higher up. This is how the bottom tiles look, and halfway up, and this is how the top ones look. Here's a 90-degree cross-section, which is rendered also via Clojure and Lux render to show how the whole structure might look like. And then finally, this is the Clojurescript application, which allowed you to use this morphogen language in a visual programming style. So those boxes here, each box is one operation in that tree, and this map here on the right shows you the entire code hierarchy visualized, which creates that object. And then if you select one of those nodes, then it is highlighted here also in the 3D preview. This is all using WebGL. So at the moment you can see I selected down here actually the seed shape, but you can click on any node and it will show you the related spot where that actually applies in 3D. And then the idea is that people submit their objects, and they can also remix their objects by choosing any of the objects in the gallery. And then you can create a kind of GitHub-style visualization and actually see how we as species recycle ideas from others all the time. And yet we claim we are creative. So here are some examples of what people were doing. And all of them are pretty basic. I'm freely admitting that. But you also have to understand this was done in a gallery context on some Android tablets, which was really not the best environment for playing around with computers. So this is something my son made. And then actually 2 weeks later, I haven't got an image now of this, but you can find it on the website. 2 weeks later, someone built an entire back part of it and turned this into a piggy bank. There are lots of animals, like a spider, insects. But it's amazing, everything comes from a single box. And that's why they all look boxy as well. Someone built a Raspberry Pi case, including a pixel font up here, which is slightly cropped, where it says RPi. And then we did some workshops as well with primary school kids in London, give them half an hour to understand programming and recursion and build that kind of Minecraft character in this tool. So, page intentionally left blank. Yeah. So at this point, I just want to very quickly run you through. And Stefan, sorry, I didn't turn the time on. How much time is left? I have not much time left. So if you are interested, you can either go to this URL. That's actually a URL. Yeah. And there you can find all the different projects and an increasing number of workshop repositories with exercises and complete projects. Just is now slightly unsorted because of Chrome tabs here. One of the libraries, for instance, is a multi-dimensional array implementation, and I also have to point out most of the libraries are both for Clojure and Clojurescript. So there's currently a port, or there's a port of Clojure core matrix underway, which is where the JavaScript version is using this as a backend. So I don't really know what the current state of this is, but check it out if you are into that. Here's another example of actually using the OpenCL wrapper for creating or implementing a renderer. So this is 500 lines of OpenCL controlled from Clojure, where you can simply define your Clojure model in voxels from the REPL, and then you kick off with a single function called a render process, which then can create those kind of images. So you could use this also for data visualization if you have, say, geological data or ISO surfaces of MRI scans, all that kind of things might be interesting. 5 more minutes, good. So this Raymarch project relies, just like the Leeds College of Music project earlier, relies on this library, which is one of the now quite many OpenCL wrappers, but it's probably one of the oldest ones. Yeah, it's from 2012. So, for instance, an example, just again to show the performance. I mean, there's a video which doesn't really show the real-time performance, but this is a mesh of 80,000 springs, and in OpenCL that takes about 400 milliseconds on my machine, which is not a fast one. In Clojure, again, we are talking over a minute. So there is a difference for certain applications where I really wish that we somehow find ways to integrate the current possibilities with the possibilities of the language. There must be some better solution in the future. So by far the largest project of the Thing project is this Geom library, which itself contains 8 different modules. And to give you an overview of this, oh, great. Okay, just new tab. So this is a diagram, a high-level diagram of the scope of that project. So you have, for instance, basic vector algebra and matrix operations. You have 20, 30 different geometry types, both 2D and 3D, from which you can convert. You can start with a circle, sample the circle, get a polygon, extrude the polygon, get a 3D mesh, and so on. You can calculate volumes, areas, all that stuff. There's Boolean modeling of meshes, where you can combine different meshes or subtract them from each other. There's an SVG module, which is, no, that's not here, 1 second. Why is this all switched? Here is a SVG module which also includes, for instance, a software renderer. This is actually SVG. So if I zoom in here, no, what is happening? Yeah, if I zoom in here, you can see this is not a bitmap image. It's actually vector graphics. But one of the reasons why I needed that, because the DevArt project I showed you earlier, this is running, the server side's running on Google App Engine, and therefore you don't get access to the Java bitmap image. Yes. So I have to wrap up, I'm afraid. So here are some more examples of working with voxels. You can create objects like this. And it's not just object-based, it's really the general building blocks. Visualization module, which is completely declarative. So you simply give it a really large hash map describing what your visualization should look like, and so on. I will have to wrap up. So I'll leave you maybe with this, but I'll leave you with that. Thank you.